Well, welcome back, my wonderful Python coders. Welcome to a brand new series on data analysis. I know it's been a while. If you used Excel to analyze data and produce visualizations, once you see what Python and Pandas can do for you, you will never go back. In this first section, section 1, we will cover a lot of ground. We'll go into what Pandas is, what are the prerequisites of this course, setting up your virtual environment, installing Pandas, generating mock data, and getting some useful Pandas terminology under your belt. We'll start to then dive into different data sets and slice and dice and analyze them. We'll cover some of the key functions and methods you'll be using. We'll sort, we'll filter, we'll describe our data, we'll concatenate, we'll slice, we'll join. We'll deal with missing data in 2 different ways, and I'll show you some useful links. This is only section 1. We have a lot more ground to cover. My goal is to make this the most useful and comprehensive course on using Python and Pandas for data analysis. So let's jump in. What is Pandas? Pandas is a Python package for dealing with data structures. It's used for working with relational or labeled data. Its focus is on data analysis and data manipulation. You can work with databases or files such as Excel or CSV files as input. You can also create Excel and CSV files as output with the data that you manipulate. There's so much to get into, I can hardly wait to expose you to it. There are certain things I won't be covering, and I'll assume knowledge if you're going to take this type of a course. Here are the prerequisites. To have a good knowledge of the Python programming language, to have an IDE of your choice installed, I'll be using VS Code, to have Python installed on your host, to have a desire to analyze data, and you know how to get around on your operating system and the command line. If you need to learn Python, we have a wonderful playlist called the Python Made Easy playlist on this very same Yogi Coder YouTube channel, and you can check it out at the link. So we can talk about installing Pandas. There are a number of ways to do it. You can use Jupyter Notebook Online. You can install it using Conda. It comes as part of Anaconda. I'm going to be using the pip install after I create a virtual environment and use it again with VS Code like I just mentioned. Okay, so here's how we set up our virtual environment. From the command line, pip install virtual env. You see for me in the green text that's already satisfied. Then I create a directory of my choice. I call it my_env using the makedir. I cd into that directory. Then I issue the virtual env my_env, which is what I'm calling my virtual environment now, same as my directory. You don't have to do it that way. That's what I'm choosing to do. And then I could start or activate my virtual environment by issuing the following command: source my_env/bin/activate. I will say right up front, I am a Mac user. Everything I do is syntax specific to Mac. So if you're using Windows, syntax is a little different. I won't go into that. Again, I'm going to assume a level of knowledge for somebody who wants to take this type of a course. But by all means, Google it, look it up. The syntax is very straightforward, very easy. In fact, I switch between Windows and Mac all the time. I had to look up the syntax today to say, okay, refresh myself with it. It's been a little while since I created a virtual environment. So don't be afraid to do that. That gets you in really great practice. All right, now we're into our IDE. This is a snippet of VS Code, which again is the IDE that I'm using. Very often, your project folder and your virtual environment folder are located in 2 different places. This is the case for me. So this is what I do. I navigate to my project folder. This is where I'm going to house the Python code that will run for the rest of this project. I run the activate command for my virtual environment from there. Okay, from my project folder by giving the full path to my virtual environment. So you see down at the bottom the example of mine, which will be different than your path. But for me, from that project directory, I do the source space /users, my first and last name, /my_env for the folder, /my_env for the virtual environment name, /bin/activate, and you're good to go. Now notice when you start your virtual environment for Python, it puts the name of that virtual environment, it prepends it at the beginning of the line, the command line, in parentheses. You see it right here. Okay, once we have our virtual environment activated, now we can do our pip install pandas from within that virtual environment. Notice we're running it with the prepended name of my virtual environment right here. You can confirm that Pandas was installed after you do your pip install by doing a pip list. And I recommend you go get some mock data that we can use to play with. I went to www.mockaroo.com. You see it here. There was some data that was already started. I added a few fields. I downloaded the data, and that's all there is to it. And here's what that data looks like. 1,000 lines of mock data that I didn't have to create. All right, and finally we're ready to start using Pandas. So let's look at the code on the left-hand side. We have to import Pandas to use it. If you've used Python before, you're familiar with that. So I import Pandas as PD, just to make it easy for myself so I don't have to continue to write Pandas. So I store my variable, my data, as my data set. So pd.read_csv, and then I give it the name of my data set as a string. I named mine mydata.csv. So that file you saw on the previous page is what we're using. Then what you see that I do here is I print that data and I slice it. I use a Python slice. I slice using 0:3 to bring back the first 3 lines of data, 0, 1, and 2, because the upper limit is not included in that data set. That's just a thing that Python does. That's nothing specific to Pandas. So you see my output right there. Okay, we're using the read CSV function because we have a CSV file. If we were using Excel or a database, we would use a different method from the Pandas library. Let's start to get some basic Pandas terminology under our belt. There are 2 primary Pandas objects, a series and a data frame. Think of a series, which is one-dimensional, as a column in a spreadsheet. Think of a data frame as columns and rows. That's 2-dimensional. So my underscore data from the previous code and right down here is a data frame. And here's how we can tell. We can use the type function, as I do here, print type my underscore data in parens, and you see it comes back as class pandas.core.frame.dataframe. Why do you care if it's a series or a data frame? Because they're similar. You care because they have different methods and syntax that you would use in certain cases. So you need to be clear. If you're getting an error, it may be because you're applying series methods when you're using a data frame. All right, we looked at the data frame. Now let's look at the series, its cousin. So here's a portion of our CSV file. We have the ID, our unique identifier, in column A, first name, last name, email, and then it cuts off. So again, import Pandas as PD. My data equals pd.read_CSV, our method, and the name of our CSV file. Then series equals my data. In square brackets, we give the name of the header of one of the columns. Now we can do a series slice. We slice the series, and we can also do the type of the series to confirm for ourselves. Now notice when it prints out, it's printing out just one column, back to that single dimension, right? It's just the one column there that represents the first name, and you could validate that against the portion of the CSV file you see on the slide. And you can also validate that this is a series because it does print out class pandas.core.series.series with the capital S. So this is indeed a series and not a data frame. So I made the comment before that you want to know when you're dealing with a series and a data frame because some of their functions and methods and properties are different. If you want to know, as you would with any data type in Python, what methods are available to you, you can print out the series with the directory or the dir method in front of that, like I have it here, print dir series. You can do the same for the data frame, whatever you name your data frame, and you will be able to see what method you have at your disposal. Here we're going to see how to get all the column header names. Down here at the bottom, line 9 of our code, print my underscore data, which is my data frame, dot columns dot values, and you see we get all the column headers in the output. This is a fairly important slide. I show quite a few things on this slide. First and foremost, we want to know how to get a subset of our data. And right here, we have the same data frame. We have a few new things going on, a few new arguments. I'm going to take you through that in a minute. But if we use the lock command, so my underscore data, my data frame dot lock, then I use the number 13, comma, And then in a list, I have first name, last name, email. So 13 is the index, the row of data. Think of index and row as the same thing. And then I want to bring back that one row, 3 different columns, first name, last name, and email. So you see that's exactly what happens. So for one record, just 3 columns. Now, what do I have in here? Typically, we've used pd.read_CSV, the method, and just fed it the name of the file, the name of the CSV. Not now. What we have here is I'm using encoding. I'm using these 3 things to help ward off some problems you may run into. It doesn't hurt to use these most of the time, all the time. That's usually how you'll see my code work. The encoding property helps to avoid decoding errors when reading data. So that's pretty safe to use most of the time. Index_col, this explicitly forces ID to be our unique identifier. Then we have low_memory. This deals with data types that Pandas believes are missing in the data population. So I have this set to false. You don't always need this, but if you run into some errors that speak to these 3 different areas, you will know to come back here and reference this slide. Okay, we're staying with getting a subset of a data. The only difference between the last slide and this, in this slide, we are going for a range. Instead of 0 or 13, we had one row 13, we're going 13:20. So it still brings back first name, last name, email, but now we have a range of rows. We use the loc property. Now we're going to use the iloc property, which is used for integer location-based indexing for selecting by position. Here we select all the data in the first record. So it's my_data, which is our data frame, .iloc, and in square brackets 0. And it brings us back our first row of data. Here we're still working with getting a subset of data by position using iloc, but now we're using 2 slices, one for the row, one for the column. So 0 through 6 will bring us back 0 through 5, because always in Python in a slice the upper limit's not included, and 0 through 2 will bring us back 1 and 2. So you see right here we have our output, and it does exactly that. And I labeled these with these blue numbers down the row and these red numbers across the column, so you could see if you get confused, it brings back 0 through 5, right? Position 0 through 5, 6 is not included, and across the top it brings back 0 and 1. 2 is not included. Always the upper limits are not included when you slice in Python. Okay, still working with getting a subset of data by position. This is example number 3. This time we use just a solo colon, and it brings us back all rows and only the first and second columns. You see this output here when it does the ellipsis. All that does is it concatenates, so to speak. It concatenates the output, because it's not going to return 1,000 rows. So you see the first 5 and the last 5. That's something Pandas does. In Pandas, we have the head method and the tail method. Head gets the first 5 rows of your data set. Tail gets the last 5 rows, and I'm showing you the output here. A very handy method is the describe method. Now, depending upon the data types in your data set, these values will change. You see for mine, I have a lot of strings, almost exclusively. I have one birth date, but I think it sees that as a string right now as well. You see that I have count, unique, top, and frequency. So let's go through those. Count simply counts how many records I have for that column. So you see first name, last name, they all have 1,000. Then we count unique values. So you see that I have some repeat values in these sets, at least for first name and last name. Email is unique. I have 1,000. Gender, I only have 2 different gender, male and female. Cities, I have only 300 discrete cities, 49 states, and so on. Now I have top and frequency. They sort of work together. Top is the largest number of values in each column. So the first name George is what I have the most of. And I have 3 of those for the frequency. You see it in the next. And Lynn Blad, I have 2 of those. Like we said, email is unique. So they picked the first one, and I only have 1 of those, right? I have 507 males, less females. I see the city of Washington 29 times. I see the state of California 120 times. And the date 5/14/20 we see 8 times. Here we are using the sort underscore values method, and we're sorting by the last name field. So we use the header of the last name, and we're able to sort by last name. So here we're bringing back a subset of data based on a specific value. This is really filtering, right? So if you see line 6, the female underscore only variable is my data set. Look at this syntax now. We have the name of the data set, then in square brackets we have it again, and then we have square brackets inside of that, and we're selecting the gender field where the value equals female. That's like that because this is a data frame, right? If you didn't do it that way, this syntax would not work, or the execution of the statement would not work. But you see, when we do that, we only bring back females in our population. Now we'll see another way to filter a data set using the IsIn method. And this is sort of counterintuitive. See what you think. So I have here New York underscore Jersey equals my data. Inside of that, again, the square brackets, just like we did, very similar syntax, my underscore data again. This time we're picking up the state column or the state field. Dot is in New York, New Jersey in a list inside of the parentheses there. So we're asking, bring me back any record where the state equals New York or New Jersey, two places I've lived in my past. Now we'll handle any records with blank data. So any record that has any missing data in any row will be dropped from the resultant data set. So you see here, the syntax is on line 5, I'm storing in drop underscore miss variable, miss, which is my data set, dot drop NA. How are we doing it? Any. So anyone at all. So you'll see we start here on the top, and the data set is less those 4 records that has missing data. Okay, so now we're doing a little bit more sophisticated action here. We are going to use those same blank cells, and we're going to fill them using fill NA, line 6 again, with the value of Washington, the string Washington. We're going to limit it to 4. Why? Because it's going to want to fill up all the rest of the records with the word Washington, and we only want it to fill these 4 for city. There is a Washington, Ohio, and there is a Washington, California. So you see the output on the right-hand side of the page. And also, this is the first time I'm showing you on line 7 how to create an output CSV file with the resultant data set. So you see I have the to CSV method on line 7, and I create a brand new CSV called replace underscore blanks.csv, which is what I'm doing. And we'll finish out this class number 1 with some concatenation and joining of different data sets and objects. So concat. We have one data set that has 10 records. The second data set has many more records than that. We concatenate them together. Then we drop any rows that are missing values, because concat is looking for equal sizes from both sets. Then I sent the resultant set to a new CSV I call to underscore DFS for data frames. And you see that on the lower right hand side. You'll notice here I'm using the keys property, and I'm feeding it 2 values, miss for my first data set and my data, the string for my second. So it creates this extra column, and it prepends it to the data set. So right there in column A, you see anything that's from my first data set called miss is there. Anything from my second data set called my underscore data is below that. We're looking here at concat and inner join together. We're going to cover joins 9 ways to Sunday in upcoming classes, but right now I just expose it to you with concatenation. So we have a concat and an inner join because we want to return only columns from both data sets. So upper right hand corner, data set 1 with 4 columns, food, colors, rooms, and instruments. Data set 2 has an ID, which data set 1 does not have, and that's fine. You're going to see why. Then we have food, colors, animal, and cars. So we have food and colors that are the same between the 2 data sets. So now let's look at our statement on line 22. So we have a variable to underscore DFS underscore join. We have PD for pandas, dot concat from concatenation. We pass it F1 and F2. Those are our 2 data sets, right? file 1 and file 2 respectively. We have keys like we've seen in the previous example, F1 and F2, and then we do an inner join. Objective is to return only those columns that are in both data sets. And if you look at the output file, you see it does exactly what it did before. F1 appears first and F2 follows. It gives us the indexes in column B for each, and then it gives us returned combined sets of food and colors, all the values from each data set respectively. Pretty neat, huh? Okay, and here I give you 2 helpful links. One is Pandas Getting Started, and the other is to generate the mock data with Mockaroo. Jump into the Pandas stuff. It's really just so fabulous. The documentation is really quite good. Guys, there is a ton more that we are going to get to with Pandas. I use it all the time at work to do data analysis, to create automated key risk indicators and visualizations. It is phenomenal. The time savings and the repeatability. It's wonderful. You'll wonder how you ever lived without it. It'll be like a cell phone. I thank you for watching till the end. If this has helped you, consider helping me by giving me a like or by subscribing to the channel if you haven't already. And most of all, if you can share this on social media sites that you partake in, that would be great, because that would help me. It would also help other people who need to get this type of content. Leave me any comments and I will try to get back to you. Thank you so much, guys.